Hello students, welcome to my class. In this video, we are going to discuss about balancing of chemical equations by taking few more examples. The first one is
butane. So that is your LPG content, large in quantity, that is butane. So when butane burns, when combining with oxygen forms carbon dioxide and water, same combustion reaction. So now we are going to write it, how to balance this type of chemical equations. So this type of chemical equations are a little tricky, and see this one, and a little special we can say, that is C4H10 plus O2, formation of CO2 plus H2O. So this type of combustion reaction is special. Okay, so I will write here, that is a C4H10, right, and oxygen plus O2, formation of carbon dioxide plus water. Okay, so now write the number of carbon atom here. So number of carbon atom here 4 is there. I will write 4. Here what is the number of carbon atom? Only 1. Okay, this is only 1. Okay, number of hydrogen atom here 10 is there. Here only 2, right? And here oxygen atom is 2, whereas oxygen atom there it is a 3. See, 3 is there. Okay, so now balance the chemical equations. Very interesting. So please see this one, little special. It is. See, carbon here 4 is there, 4 is there. To balance this chemical equation, I will write 4 behind this carbon. So when I write the carbon dioxide coefficient 4, so now the carbon atom is 4 at both the side, it is now equal. Okay, when I write here, so 4 of 2 is 8 plus 1, 9. Okay, so wait, and next hydrogen atom. So number of hydrogen atom here 10 is there. Here what is there? Only. So that's why only 2 is there. So I will write here 5. 5 of 2 is 10, and here become 10. So now the chemical equation is balanced. But the number of oxygen atom changed by doing while balancing the carbon and oxygen atom, hydrogen atom. So what is the number of 4 of 2 is 8 plus 5. So total, instead of 3, now it will become 13, right? Here 13 is there, here 2 is there, and how we are going to balance it? Yes, see, to this oxygen 13 by 2 is means about what you have to multiply 13 by 2. Yeah, so I have written 13 by 2 here. Half of this when multiply to 2, so we will get the total number of 13 oxygen atom. But there is a condition that while balancing any chemical equation, we should not write the fraction, always write the whole number instead of writing fractions. So that what to do here now? Now this is 13 by 2. Now what denominator is there? This denominator, right? This denominator, what is there here? 2. Multiply with this to the whole equation. What is there here? 2 is the denominator. Multiply the whole equation by 2. When you write like this, what it becomes? It becomes 2C4H10. Okay, C4H10 plus into 2 means 26 by 2 means again it becomes 13O2, arrow mark. So 4 into 2, that is 8 CO2, yes, plus 5 to 10, 10 H2O. See, there is number of so these all are doubled now. It become 8, it become 20, it become, yes, it become 26, and this also become 26, and this also become 20, and this also become 8. See, 8, 26, 26, 8, 20, 26. Now the chemical equation is completely balanced. Yes, is that clear for you? See what I done to remove this fraction. I have multiplied the using the denominator. I multiplied the whole equation. When I multiply with the denominator, the whole equation it becomes changed, and 2C4H10 means 2 butane when combined with 13 molecule of oxygen, it forms 8 of carbon dioxide and 10 molecule of water. So this is the balanced chemical equation. This is the way how to balance this type of chemical multiplication you have to do by using the denominator. So this is the one the important thing that you have to remember while balancing the chemical equation. So some of the chemical equations are too much complex. And during that type of chemical reaction, they are made up of polyatomic equations there, guys. So during the polyatomic equations, balancing the chemical equation by considering their ions. You have to consider the ions while balancing the chemical equation. So let us discuss such a one or two examples, and that will help for us to balance such a type of chemical reactions. Okay. So now what I have taken an example of such a polyatomic equation, that is NH4 thrice PO4. What is the name of this compound? Yes, you are correct. It's ammonium phosphate. It's ammonium phosphate. So BaOH twice means barium hydroxide. Barium hydroxide. And what is the formation? Ammonium hydroxide. It becomes ammonium hydroxide. And what is the barium phosphate. Barium phosphate, right? So this is a chemical equation. During this type of chemical reaction, what I said, you have to balance by taking the complete ions. Here I have, what are the ions present here? NH4, an ion is there, PO4, phosphate ion is there, Ba plus and OH minus. So these are the chemical equations that are present in this equations, and you have to balance it. So how many NH4 are there here? Can you? Okay. So how many number of the NH4 are so NH4 ion is there? So that is yes, you are correct. It is 3 multiplied. 3 is there. Here it is only 1. Right? PO4, yes, it is 1 here. Here 1 here. But PO4 here 2 is there. Right? You have to consider the full ion, not 2. And next barium, here 1 is there. Yes, here it is 3, right? Ba3 is there, right? And OH ion here 2 is there, and whereas here 1 is there, only OH, only 1. Right? Is it clear? So now, so here 3, here 1 is there, 2 is there, 1 is 3 is there. So almost all it is imbalanced. It is completely an unbalanced chemical equation. Okay. So now we'll balance it now. Okay. So first we'll start with barium. So barium 1 is there, here 3 is there. I will multiply the barium by 3. So when I write this one, barium atom both the sides is equal. Now the equation is balanced. Not the equation, only the barium atoms are balanced at both the sides. So when I write here, there are some number changes. That is the OH ion, it becomes 6 because 3 of 2. Here it is 1. Okay, we'll balance later. So now take ammonium. Ammonium, how many is there? 3 is there, here 1 is there. Yes. Here 3, here 1. Okay. And before that, we'll take, okay. See, hydroxyl ion first, I have balance the first hydroxyl ion, right? OH 6 is there, here 1 is there. So to make it 6, I will write here 6, right? Okay. When I write 6 here, the NH4 also becomes 6. Now this is also balanced and this is also balanced, right? When I write there, the ammonia also increased by 6. So this side also NH4. So now it becomes 6 now. But here 3 is there. So to make it 6, I will write here 2. When I write here 2, this NH4 also becomes 6. Now this is also balanced. See the PO4. PO4 here, 2 PO4 are there. And here also 2 is there. It also becomes balanced. So now 6, 2, 3, 6, 6, 2, 3, 6. Now the chemical equation is balanced. Okay. This is the way of balancing polyatomic equation, and I will give one more example of that, and you try and verify your answer by afterwards.